Hello, everyone. Welcome to Lecture 12 on Introductory Statistics. Now, in today's lecture, we're going to talk about the mean and standard deviation of a discrete random variable. Okay, so firstly, let's check the definition of the mean. Okay, now let X be a discrete random variable. The mean or the expected value of X is, given below. This one is mu, right? It's a Greek letter mu equals notation expectation of X equals the summation. Right? This is the summation sign over X, X, P of X. So where the summation is over all possible values X of X. Right? The mean can be interpreted as a long-run average of the random variable if the associated random experiment is repeated for many times. Okay, so let's just explain this one in this way. Say that this is my X, this is my probability values. This is X1, this is X2, and XR. All right, so this is going to be P of X1. P of X2, and here is P of XR. Say that this is our probability distribution. Okay, then what is going to be the mean? The mean, all right, expected value of X equals what? Equals the summation of these products. X times P of X. So we are going to have X1 times P of X1. So X1 P of X1. So this is the first product. And plus X2 P of X2. All right. And then we add them up all the way till P of XR, XR P of XR. So this is summation of all the products is the mean or is the expected value. Okay. So that is what we mean by the mean. All right. So it equals what? X1 P of X1 plus XR P of XR, right? The total summation. Now let's consider an example here. All right, Tom wants to play a basketball game at a carnival. The game costs the player $5 to play. The player gets to take two long-distance shots. If the player misses both shots, he or she gets nothing back. If the player makes one shot, he gets his $5 back. If he makes both shots, he got $10 back. All right, so Tom has a 40% chance of making this type of shots. If let X be the amount of money Tom gains from playing this game in one trial, we want to construct the probability distribution of X, and B, we want to find the mean of X. Okay, so here, let S be represents success in making a shot, and F represents failure to make a shot. Okay, then the possible outcome of these two shots. These two shots are going to be what? Success, success, both succeeded. Success, fail, fail, succeeds, success, fail, fail, right? So then in order to construct a probability distribution, we need to find out the list of possible values of X first, right? So what are the possible values of X? All right, what are the possible values of X? All right, so the possible values of X are what? So here, the player got to pay $5, right, to play. Now, if he misses both shots, he got nothing back. So in this case, if he or she misses both shots, then he got nothing back, but he paid $5. Then the amount of money Tom gains is going to be what? It's going to be -5, right? It's going to be -$5. Now, the second case, if he makes one shot, just one shot, he got his $5 back, then the amount of money is you just break even, right? Pay the $5 and got the $5 back. So that's going to be $0. And then finally, if we mix both shots, they got $10 back. So that's 10 minus 5. That's what they got. They gain $5. So the possible values of x are -5, 0, and 5. Okay. So then we want to find the probabilities, right? So corresponding probability values. So what is the p of -5? So as we know, by definition, that's the probability for x equals -5. Now, when x equals 5, -5, that is to say when the player misses both shots. That's what? FF, right? So that's probability for fail and fail. So now this one equals what? We assume that the shots are independent. All right, so it equals a probability of fail for the first times the probability to fail for the second, right? So because they're independent, we say that's the product. Now, what is the probability of fail? All right, misses the shot. That's going to be a 40% chance of making this type of shot. So fail to make this shot is going to be 1 minus 0.4, right? So here is 1 minus 0.4 again. Now that's what? 0.36. Okay. Now this is the p of -5, and then p of 0 equals the probability for x equals 0 equals there is only one shot, right? One success. So p of what? SF or plus p of fs. Okay, so this one equals p of s times p of f plus p of f times p of s. So this one equals what? P of s is 0.4 times 1 minus 0.4 plus 1 minus 0.4 times 0.4. Okay, so if you add them up, you got this is 0.48. Okay, it's 0.48. Now finally, we have p of 5 equals p of x equals 5 equals, they both succeeded. They make what? They makes both shots, right? So make both shots, that's S. So p of s times p of s equals 0.4 times 0.4 equals 0.16. Okay, equals 0.16. All right, these are the corresponding probabilities. Now let's put them together for the probability distribution. The possible values are -1, -5, 0, 5. These are the corresponding probabilities. So the probability distribution is x here, p of x is -5, 0, 5, and this is 0.36 and 0.48 and 0.16. So this is the probability distribution. All right, now B. Find the mean value, right? So what is the expected value of x? Okay, so here the expected value of x by definition it equals the summation of this product. Okay, so here possible value of x is 95 times 0.36 plus 0 times 0.48 plus 5 times 0.16. Now this one equals what? If you add them up, you got this one is -1. Okay, so the expected value is -1. So how to interpret this -1? Expected value equals -1. So x is the amount of money Tom gains from this game in one trial. So -1 means what? Tom is going to lose $1, right? So Tom will lose $1. The expected amount of money Tom gains from playing this game in one trial is -1. He will lose $1 on average. All right, for playing this game. Okay, so now here this -1, all right, is negative. Means what? On average, Tom will lose money. Lose how much? is $1. Okay, so why this is negative $1? And you can see that. So it can lose $5 with a probability of 36%, right? It break even with a probability 48%. Now it win $5 with a probability 0.16, right? So as you can see, he has a higher chance of losing $5 than what? Than gaining $5, right? Now the middle one, it breaks even, so it doesn't matter. But he has a larger chance of losing $5 than the chance of gaining $5. So that on average, he's going to lose money, right? He's going to lose money, and lose how much? As we see, the expected value is -1. Okay, so therefore, this is how we interpret the outcome here. All right, the expectation is -1 means in the long run, Tom will lose money. Okay, for this game. All right. Now let's consider another example. Let X be the number of vehicles owned by a randomly selected household from a certain region. The distribution of X is given below. Find the expected number of vehicles owned by a randomly selected household from this region. Okay, so now how to find the expectation? Okay, so we know, right? The expectation equals the summation of the products over X. So we see that 0 times 0.10 plus 1 times 0.20 plus 2 times 0.35 plus 3 times 0.25 and finally 4 times 0.10. And you can calculate that. You got 2.05. Now, how can it be? Okay, so we got this one, right? So we got this one. This is the sum of the products X P of X. So we found it's 2.5. But does that make sense? Now here, X is what? X is the number of vehicles. Now your value is 2.05. But does that make sense to be saying that it's 2.05 vehicles? What is the problem here? Right? So you're talking about the number of vehicles, but what you get, a expected number is decimal points. So what is the problem? What's wrong with it? Now here, nothing is wrong, okay? So you have to be careful. The expectation of a random variable is a theoretical average of the random variable in the long run, okay? So now, for instance, if household 1 have 1 vehicle, household 2 has 2 vehicle, right? Then what is the average number of vehicles? It's going to be 3 over 2, that's 1.5, right? So the average is 1.5, okay? So if you interpret the expectation as the theoretical mean or the long run average of a random variable, when this random variable are repeated many, many times, then the average can be a decimal point, right? Even though we know that the number of vehicles X it can be 0 is an integer, 1 is an integer, 2 is an integer, 3 is an integer, 4 is an integer. They are all integers. Those are the possible values of X. But the mean is a theoretical average. It's a theoretical mean. It is a long run average among many, many households, right? So therefore, the average can be what? A decimal point. So here 2.05 makes sense. All right, so be careful on that. Now, another concept we want to talk about is a variance and standard deviation. Okay, so for any random variables, one interesting fact is about the mean, theoretical mean, like we just discussed, right? The average is a long run average, like the oil price, right? So the currently the oil price is pretty high, right? So, but also another aspect of the random variable is the variability. Now, how they spread out, how spread out all those values, all those random variables, right? So it may change from, one day it is pretty high, the other day it drops, and then increases, drops, and so on. So that's going to be something we have to be careful. So that's the variability. Now, there are two very important measures of variability. So one is called the variance, the other is the standard deviation. So now let's consider the definition of them. All right, let X be a discrete random variable, the variance sigma square. Okay, so this is the notation of the variance of X is, all right, either you use sigma square or VAR, variance of X equals what? The summation over X. Here is their square, X minus mu. Here mu is the mean, right? So X minus mu is going to be the deviation of X from the mean, right? And then you take the square the deviation, right, from the mean, and then times the corresponding probability. Now this product, you take the summation over all x's, right? And then you got the variance. So the variance is basically the expected value of the squared deviation of x from the mean. Okay. So in terms of calculation, this formula is preferred usually. All right. So this one equals what? The summation of x squared p of x minus what? The square of the expectation, right? So which is the mu, right? Or you can write down as what? Summation x squared p of x. So minus, all right, the square of the expectation. Okay, so this is the variance. This is the variance. And then standard deviation is what? It's the square root of the variance. All right, it's the square root of the variance. Now, one thing you have to be careful is the unit. The unit of the standard deviation is the same as the random variable, while the unit of the variance is the square of the random variable. Okay, so for instance, if x is measured in feet, then this is also in feet, but the variance is going to be square feet, because as you can see, we are taking squares, right? We are taking squares here. Now consider this example. In example 5.5, we want to find S variance and standard deviation. So this is the distribution about the in example 5.5, right? So as we know, it loses $5, right, with probability 0.36. Break the even, probability is 0.48, and win $5, lose with the probability of 0.16, right? And we found that the expectation equals what? Equals -1, right? On average, it will lose $1. So now we are to find the variance and standard deviation. How to find the variance and standard deviation? Okay, so firstly, the variance, as we know, this formula equals what? Summation of x squared p of x over x minus the square of the expectation. Now this is the formula, right? This is the formula for the expectation, for the variance. Okay, as we see that this one equals this, right? Now, I think this is already known. Now we already found this one is -1, so this term is okay, right? It's taken care of. Now the next thing is we need to find out the first term. What is the value of the first term, right? So if we can find the value for the first summation, then just plug in the values. Everything will be good. Now, how to find this first summation here? So let's do this one. All right. So this one, summation x squared p of x. So now you're going to take the square of the x values and then multiply its corresponding probability. So for instance, this is the -5 here, right? So -5. So I'm going to take the square of -5 times what? Times the probability 0.36. And plus, here is going to be 0 squared times what? 0.48. And finally, 5, take the square, and then times its probability. Okay, so now you can put them together using the calculator. You can find this one equals what? It equals 13. Okay, so this summation equals 13. Therefore, what? The variance of x equals, all right, summation x square p of x minus the square of the expectation equals what? 13 minus -1 squared equals 13 minus 1 equals 12. So this implies what? The standard deviation sigma equals square root of the variance equals the square root of 12. Okay, you can calculate. You can calculate this one. Is that 3.46? I forgot the value. All right, you can use a calculator to find this one. I forgot. Okay, so you can round to 3 decimal places, but you can also just leave it like this. Okay, that's a standard deviation. All right, so let's go through this one. We have this distribution. Now we firstly found the expectation, and then we want to find this summation, right? The summation can be found using this one is 13, and plug in the formula. We found that the variance is 12. So the standard deviation is simply take the square root of the variance. All right, so we have that. Pretty simple, right? Okay. Now let's consider another example. Consider this example in example 5.6, find its variance and standard deviation. Now again, this one we in the previous example we already found that this expectation equals, is that 2.05? All right, so I think it's 2.05, right? So now we want to find the variance. So what is the variance? Now again, we firstly find the summation of x squared p of x. So it's 0 squared times 0.10 plus 1 squared times 0.20 plus 2 squared times 0.35 plus 3 squared times 0.25 plus 4 squared times 0.10. So this equals what? This equals what? 0.2. Okay, I believe it's 4.45. All right, so you can calculate this one. It is this one, and then this implies the variance, okay, of x equals what? This is summation x squared p of x minus the square of the expectation, okay, equals 5.45 minus 2.05 squared. What is this? 1.2475. Is that right? I forgot. All right, so it is this one. All right, so you may use the calculator to find this value. This is going to be the variance, and then you can take the square root, right? The standard deviation is simply square root of the variance of x equals square root of 1.2475. So I believe it's 1.117, something like this. Okay. Now if you run 3 decimal places, okay, so you got this one. All right, so this is how we find the variance for this one. Okay, so we're going to stop here for this lecture, and I will see you in the next time.